Introduction: This study uses a quantitative approach to examine the link between tensile strength and density, from data from 20 materials we gathered from reliable sources, with tensile strength as a S and density as a Y. Statistical methods including confidence interval, hypothesis testing, and linear regression were used. Results show how density influences tensile strength through gauge correlation and R-squared value. AI tool added data collection, but all analysis was done manually by the research team. This data we gathered from AI, and tensile strength is S and density is Y.
Hi, Assalamualaikum. My name is Roy.Myra binti Resmairoha and my metric number is CN240279. I would like to continue with the literature review. For the chapter 4, estimation involve inferring a population parameter from sample data. There are two main types. Point estimation, which give a single value example like sample mean, estimate population mean, and interval estimation, which provide range likely to contain the parameter. To construct a confidence interval for the population mean or variance, HS important to choose the correct distribution based on sample size. Use the Z distribution when the sample is large or the population standard deviation is known. Use the T distribution when the sample is small and standard deviation is unknown. Confidence intervals help make informed decision by showing the range where the true parameter likely lies, usually with 95% confidence. For the chapter 5, hypothesis testing or significance testing is used to draw conclusions about a population based on sample data. It starts with stating the null hypothesis HO, which assumes no effect, and the alternative hypothesis H1, with the contradicts rationale. We calculate a test statistic Z and T and compare it to a critical value or p-value to decide whether to reject rationale. A type 1 error occurs when rationale is wrongly rejected, produces risk, while a type 2 error happens when rationale is wrongly accepted, consumer risk. Tests include the Z test, known variance, and T test, small sample or unknown variance, and square test, categorical data. This process support database decisions and validate research results. The last but not least, for the chapter 6, simple linear regression models the relationship between two variables, one independent X and one independent Y. A scatter plot shows their relationship with X as the control variable and Y as the response. The regression line fitted using the least square method. The closer the data points to the line, the better the model fit. The coefficient of determination R square measure how well X explain Y. This method is useful for predicting trends in fields like engineering, science, and economics. I will continue with the methodology part. This study uses a quantitative research designed to examine the relationship between tensile strength and material density. A data set of 20 materials was collected from reliable secondary sources with tensile strength as variable X and density as variable Y. Statistical methods such as confidence interval, hypothesis testing, and simple linear regression were applied to analyze the data. The results show how well density predicts tensile strength based on correlation and determination coefficient R square, while AI tools like ChatGPT help in data collection. All analysis was done manually by the research group using proper statistical methods. That's all from me. Thank you.
Good morning. My name is Leno Luguana John. My matrix number is CN240115. In chapter 4, we focus on estimation which help us approximate unknown population value by using sample data, we apply both point and interval estimate with the 95% confidence interval being a key tool. As shown in the calculation, confidence interval give us a range of value rather than a single point, allowing for uncertainty in prediction. For instance, the tensile strength had a confidence interval from 1 at 1.93 megapascal to 510.087 megapascal, and density range from 2 at 39.19 to 6900.81 kilogram per meter cube. This method is beneficial because it allows us to make informed decisions without requiring complete population data. It also shows us how sample size and variability affect our level of confidence in the result. Moving on to chapter 5, we apply hypothesis testing to determine if sample data could support or reject a claim about a population parameter. We use one sample of the test, and in our example, we test whether the mean tensile stress was equal to 1500 megapascal using a significant level of 0.05 and 90 degrees of freedom. Our calculated t value was negative 13.435, which is far beyond the critical value of 2.093. Because of the test statistic fall in the rejection region, we reject the null hypothesis. This means the average tensile strength is significantly different from 1500 megapascal. This chapter emphasizes the importance of p-value and significant level in validating claim and identifying meaningful difference with statistical confidence. That's all for me. Thank you. Finally, in chapter 6, we use simple linear regression to study the relationship between tensile strength and density by plotting the data and calculating the slope and y-intercept. We found the regression equation to be y equal to 4122.294 plus 2.161x. This means that for every unit increase in tensile strength, the density increased by about 2.161 kilogram per meter cube. The correlation of coefficient R equal to 0.1746 show a weak positive relationship between these two variables. The relationship is not very strong. The regression still help in understanding how one variable affect the others. This method is widely used to make the prediction in real world of engineering application. That's all for me. Thank you.
Conclusion: In conclusion, the study used various statistical methods to analyze the relationship between tensile stress and density in 20 materials. Estimation provide confidence interval for the mean and variance, helping generate findings. Hypothesis testing allows us to accept or reject claims with statistical confidence. Simple linear regression have a clear relationship between two properties, with a square indicating how will density predict tensile strength. Overall, the analysis differs strong, like with material and height, highlighted the value of a data-driven approach in material selection and engineering.